All right, so we've just spent the last several weeks getting a good grasp of data wrangling tasks. Now, for some of you, this is the last week of class, and we're just going to do a quick introduction into machine learning and how to apply it within R. For others, we're going to actually end up spending the next several weeks getting deeper into the different algorithms, right? But before we do that, an important question to answer is, what exactly is machine learning? And in a nutshell, it's all about identifying patterns and relationships within our data. Now, we spent time visualizing data, and we know that often when we're just looking at simple relationships, we can see distinctly patterns within our data, right? Whether it's a linear relationship between two variables or a nonlinear relationship, maybe there's separation within our data, whether that's separation as in groupings that exist or just separation in how certain groups of individuals or observations behave to decide if they're going to maybe click on a ad or not, right? We can see all these relationships fairly simple when we're not looking across too many variables of interest. But a question gets raised is, what happens when our data get far more complex, right? And we don't have the ability to simply assess the patterns and relationships visually because the relationships are very complex and there's a lot of variables in interest or a lot of variables of interest that we want to look at. And then also the question is, how can we reuse the patterns that we do observe in order to help decision makers answer questions or make decisions on the way forward for certain tasks? Right, and this is the idea of machine learning. Machine learning provides us a set of algorithms to identify patterns and relationships across our data and apply those patterns for the purpose of aiding decision makers. Right, so examples can include using information on patients to predict the likelihood of a patient returning to the hospital, which we call readmission. We may also want to ask the question of, is it possible to segment our customers based on common attributes or purchasing behavior so that we can do targeted marketing? Or maybe we want to predict coupon redemption rates for a given marketing campaign, and that could be based off of customer behavior and also the type of campaign that we are going to run. Maybe we want to predict customer churn so an organization can perform preventative intervention in order to retain customers longer than we would expect to. And there's many other examples. Now, when we talk about finding patterns within our data, we actually find patterns for different reasons. And we can kind of group these into two large tasks. The first task is supervised learning. And we use supervised learning for the purpose of making a prediction on what we would call a certain output, right? Or what we call a target variable based off of other input variables or features in the data set. Then the other task is unsupervised learning. And the idea behind this is using information about our observations or common characteristics within our data in order to group data, whether that be across observations or variables or columns. Right, so let's look at the supervised learning. Right, the idea is we want to model a relationship between a target variable, which is a variable being predicted, and the other features in the data set, which we often refer to as predictor variables. Now, some examples are shown here where we want to use customer attributes, right? In blue, those are the features. Those are the predictor variables. We want to use customer attributes to predict the probability of a customer churning in the next 6 weeks, right? So here, customer churning is what we want to predict. That is our target variable. Another example is using home attributes to predict the sales price, right? So in this case, the sales price of a home would be what we want to predict. That's the target variable. And the home attributes, right? Maybe the square footage, number of bedrooms, the quality of the kitchen. Those are all predictor variables that we could use in order to predict the sales price, right? And there's additional examples here on this slide. Now, within supervised learning, we often have two primary tasks. Right? One is to predict a continuous variable or continuous outcome. So for example, say we want to predict the sales price, which we can kind of see here on this vertical axis. The sale price dependent on a couple of features, right? One could be year built, which we see down here on this lower axis. And then also over here we have, let's see if I can get this over, square footage, right? So this is actually kind of a three-dimensional regression problem here, where we have our sale price, which is a continuous number, maybe between 150,000 all the way up to 350,000, based off of different features. We call this a regression problem. When the output variable that we're trying to predict, the target variable, is a continuous number, then we call that a regression problem, not to be confused with linear regression, the algorithm. Now, another problem is when we want to do what we call a classification problem. This is where we have different features. So, for example, maybe the age of a patient, the family, the family history, their family medical history, and then their current symptoms. Right? These predictor variables could all go into a model for the purpose of predicting yes or no whether this person will likely be coming back to the hospital. Right? Now, this is what we call a classification problem. The output variable of concern here is categorical in nature. In this case, it's binary. Or we may be trying to predict three outputs, such as low, medium, or high. Right? This is what we call a classification problem. All right, so regression problems and classification problems, they're all for the purpose of predicting some output, and that's a supervised learning problem. However, another task that we often want to do is simply to identify groups within our data. And these groups are not supervised by any target variable or output variable, right? So in this case, we call this unsupervised because in these examples, how we train our data or how we find these groupings is not supervised by a target variable. It is unsupervised, right? And the two main approaches to unsupervised learning is when we are trying to group our observations based off of, group our rows in our data based off of common characteristics. And we often call this like clustering, right? We're trying to find clusters or groups of common observations or observations that have common attributes amongst them. Now, another unsupervised approach is when we want to reduce the number of columns, and we often call this dimension reduction. Now, we use this often in conjunction with other modeling tasks, which we will see later on in this course for those that are continuing on. But a classic example is principal component analysis. That's the idea of reducing the number of features in our data set based off of the level of correlation, right? So we are reducing our features based off of common attributes or common behavior. All right, so within R, it's important to understand that we have a lot of options for doing modeling. We have many, many, many different packages that implement different types of machine learning algorithms. And that's all great. But often it does bring up another concern in that they don't all behave in a similar nature, right? Or maybe the syntax is different between them. And it makes learning all these different packages very difficult. Now, very much like we learned about the tidyverse in the last few weeks, where we have a group of packages that make the data analysis process, the data wrangling and visualization process within a data analysis project very easy because we have similar syntax. They behave in a common manner, and they can interact with each other very easily. We have the same thing within the machine learning ecosystem within R. And there is a growing ecosystem that we call the Tidy models that is a collection of packages that is targeted for specifically modeling and machine learning workflows. And they all follow the same tidyverse principle. So the beauty of this is now that you learned or understand the tidyverse ecosystem and the kind of the principles and syntax that goes with tidyverse, we're going to see a lot of that flow into this new ecosystem of packages we're going to use called Tidy Models. Right, so just realize that there's many different ways we can actually implement modeling within R. We're going to focus on the Tidy Models. This is becoming a more popular ecosystem to use, and it's going to continue to grow in capabilities. All right, so with that, I want you to dig through the reading, this lesson reading, and then we're going to jump on to actually starting to implement some machine learning models with our data.